everyone. Good evening, everyone. Welcome back to the Astro Imaging channel. We've got another great show for you tonight. This is the third program that we've had over the last few months about the upcoming eclipse, which now is just less than a month away. And so we've got Eric and Tim are going to talk to us tonight about automated eclipse imaging. So I know we're all looking forward to hearing about that. Before we get to that, though, I did just want to mention the TAIC workshop that's also coming up. We've got the workshop episode scheduled for March 31st, and that's the M101 data, a really nice data set from Eric's 20-inch plane wave. And if you'd like to work that up and participate, maybe be involved in presenting on the show, then get that in there. We need to have that submitted no later than March 17. So that's next Sunday, a week from today. So I really would encourage everyone to download that data and work it up. It really is a nice data set. So. And then next week, we've got Craig Stocks with us. Craig's been somewhat of a regular on the show recently, and now he's going to talk to us about building his remote observatory in Utah. And Craig's with us tonight. So Craig, would you mind giving us just a brief overview of what you plan to talk about next week?
Yeah, sure. About 3 years ago, actually, almost 3 years ago to the date, we made a decision as a family to start a remote observatory operation here in the desert in southwest Utah. And we now have two pretty good sized observatory buildings. One's 24 by 40, one's 24 by 60. Gradually, the first building is full, the second building's about half full. So I wanted to share some of the process of how we went about setting up and building the observatories and some of the lessons learned along the way.
Well, that sounds great. That should be a neat show. And I've seen a number of videos on your YouTube channel with your site there. It looks beautiful. So it'll be neat to get a little closer look at what went into putting that up, because I imagine that was a pretty big undertaking. So. All right, so that brings us then to tonight's episode. And as I mentioned, we've got Tim and Eric are going to teach us all about automated eclipse imaging. Are the two of you ready to take over?
Tim, I'm ready. Let's do it.
Let's go.
Take it away.
Eric, you want to bring up the presentation? And
all right.
Start
Give
there?
me just a moment.
While Eric's bringing that up, folks, we're doing things a little bit different tonight with two of us talking, and so if we fumble the ball a little bit, why, rest assured we're trying to get it right. So,
Give me just a moment. Bring that up. Can we see that?
yes.
Yes. Yeah, it's looking good.
Okay. So as Patrick said, we're going to talk a little bit tonight about automating the imaging process during the eclipse. And we heard a presentation a few weeks ago about how you can do it without any automation and sort of manually clicking through with your camera. But Eric and I had a different approach. I'm going to be showing you how I'm doing it on a Mac platform. Eric's going to show you how he's doing it on a PC platform. So, we should have something for anybody that is interested in doing this sort of thing. So, Eric, why don't you go on to the next slide, please? My name is Tim Hutchison. You guys know me. I'm a retired CEO from a software company. I started out in landscape photography. I got into astrophotography in 2018. I operate a telescope out at the SRO, a remote telescope. And Craig, don't hate me. And I have a backyard observatory with a TOA 130 and with a custom solar telescope.
You got to say next slide, Tim.
Next slide. It's your turn.
My turn. Okay. Well, come on, baby. Next slide. Next slide. I have a 20-inch plane wave out at the SRO on an L mount and a Moravian camera. And I'd like to show a picture of me sitting in front of the telescope, but I've never been there. So the only person among the two of us that's been there is Tim. So we got a picture of Tim and Tony in front of my telescope. So
My wife is going to love the fact that she was on the program tonight.
yeah, so she's on the program. I'm a PhD research biochemist. I'm still kind of active in drug development. I started astrophotography in 2011 when I came back from a stint in China. I've been imaging at the SRO since 2014 and now have the Planewave. This is my third scope out there. I started, like most of us, on a back deck and soon migrated out to the SRO because I met the fellow who owned the SRO, and I've been doing that ever since. And that's my setup. And I only have a picture with Tim out there.
Okay, so what we're going to talk about tonight is, like I said, how we're going to automate things. Whoops, see, too quick. So we're going to start off with our imaging rigs, and so just stay there, Eric. Okay.
Sorry, I didn't click anything. It did it by itself.
That's all right. We're going to start off with our imaging rigs, and then we're going to go through two different packages for automating the photography session. I'll be showing you Solar Eclipse Maestro, which runs on a Mac, and Eric is going to be showing you Eclipse Orchestrator. If I could talk tonight, it'd be easier. But we're going to go through the setup, creating a script, how we practice, and we'll show you the software real quickly. So go ahead, next slide, Eric.
And what I have up here is, I guess, what I call the money shot. So if you're going to do Eclipse photography, this is the shot you want to get. And if we get nothing else, that's the shot I want to put in my system. Let's go to the next slide.
So this is my rig, and you can see it in the camera behind me here. I brought it there just so if we need to look at anything, we have it. But I'm using a ZWO FF80, an 80 millimeter, 600 millimeter focal length f5 or f7.5 telescope. I have it on a Rainbow Astro RST 135E mount. We're going to be talking about the guiding solution that we're using, which is the high node solar guider, which we'll talk about here in a second. I'm using a Nikon D810 camera and the ND5 solar film filter from Spectrum Technology.
Next slide.
Next slide, Eric.
I have a little different picture of what I'm doing. This is my practice out on the back deck. And I'm using, what am I using? A Rainbow Astro 135, Telescope Systems 80 millimeter f6.8. I think it has very similar focal length as Tim's. Same high node guider. I have a Canon 80D DSLR, 1000 Oaks filter. And besides my HV computer and Eclipse Orchestra software, all these other setup accessories. We're going to talk more about practice. And so I wanted to show a picture of everything it took for me to practice without actually being in the Eclipse. And that list on the right is my list. We'll talk more about that later. Next slide.
Okay, so I wanted to talk a little bit about what you can expect to see if, like me, this is the first time that you're going to try to photograph the eclipse. And so I found this website, MrEclipse.com, that had this presentation here of different focal lengths and different camera sensors and how you could, what you would expect it to look like. So what you see over there on the right is the numbers in blue are for a crop sensor. The numbers in black are for a full frame sensor at that focal length. And so, I saw the full frame at 500 millimeters and I said, well, that's close to what I want to shoot for. And you can see my actual, one of my actual images from testing, which is the image on the left side down there with the orange sun. That's one of my images from testing. So that's how big I expect the sun to be. Well, that's how big it's going to be, not how I expect it to be. That's how big it's going to be in my 600 millimeter focal length with a full frame sensor. But if you're looking for a different shot, I thought I would show this to you so that you can see what it would take to get you know, a different size Eclipse image in your frame sensor.
And I'm shooting at 654, so probably the image in the lower left is what I'm going to get, and it looks very similar. Sun is slightly smaller, and I have about 3.5 solar radiuses across and about 3 solar radiuses up and down, and that should get a pretty good image of the corona. Tim, you're going to get a little bit wider, so it'll be interesting to compare the two.
Yeah, right. But you know, with the resolution of these cameras nowadays, you know, frankly, you know, cropping and making that appear to be bigger is not going to be an issue if I end up with a whole bunch of black space around it. So I figured I'd rather have the slop and have some space there and crop it later if I have to. So that was kind of my thing. Next slide. There we go. So let's talk about the solar guider. We found this, Eric and I both kind of found it from somebody talking about it for a different purpose. And I said, gee whiz, I wonder if this will work on the Eclipse. And it turns out it will. What this device does is guides on a full lunar disk. And so I just have it sitting in a, you know, in a dovetail there on my telescope. The guider is the white box that you see on the right. And the hand controller is the little box that I inset there on the left. You know, this has a, like I said, the ability to guide on the full solar disk. So precise alignment, precise polar alignment is not as critical, right? I'm just using, in my testing sessions, I just used a compass, you know, of course, accounting for magnetic declination, which we can talk about if there's questions about magnetic declination. But I used a compass and, you know, pointed it north, and I used a clinometer to, you know, to set the deck, and that's it. Now the guider has what they call a course finder. So if you look at the front of the white box, you see sort of a little pyramid with a hole in it there. And on the back, you see a pyramid with a yellow spot. That's a solar finder, and it'll project the sun on the back. So you move the sun into that yellow disk, and you're pointing at the sun. With that, there's a fine finder. If you want to use it, you can press finder on the controller. You see the blue finder button there. And it'll sit there and beep, 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 beep at you as you get it closer and closer to the sun. When you're pointing at the sun, you press the calibrate button. It moves up, down, left, right, gets its calibration, and that's it. You press guide and it starts guiding. There's no computer necessary, nothing. The only thing you do have to account for is a meridian flip, which we'll talk about later. But it's really very simple, and you know, you're able to store a configuration for before and after the meridian in there. So I think it's pretty slick. Eric, anything you want to add to that?
Yeah, before this came out, and I have to give Tim credit, I didn't find this, or if I did, I've forgotten about it. But before we came up with the high node guiders solution, you're out there in the sun trying to line your telescope in the center of your frame and hoping that your very coarse calibration when you do your polar alignment is going to stay through the eclipse. And anytime you interrupt the whole process to recenter it, you interrupt the automation. And so I came up with all sorts of concocted solution, like putting another finder in there, which was not good. And the other one, I mounted my solar telescope on top of the telescope. And that wasn't good because I'm in the bright sun trying to look at the sun. It was just a mess. And so this took away one of the primary problems that you have with keeping the sun in the center of the frame during the eclipse, so you're not mucking around with it. You're letting the automation do its job. And I've run half a dozen tests, and it works perfectly well if you take your time and calibrate it. By the way, this is, I don't want to say an expensive thing, but it's something that is not inexpensive, but hopefully we can use it in our other solar imaging. So this was a godsend. This was a solution that was really important to us.
And, you know, speaking to the expense, you know, I'm probably going to get, one shot at this. The next eclipse is what, 30 years from now in North America. So, I got one shot at it. So I figured it, a little bit of investment is probably worth it for me.
And that's the point of this whole presentation. You have your 4 minutes. That's all you have. So everything really has to be perfect. We'll talk about that more later.
One more thing that I didn't mention is that this does plug into the ST4 port on your mount. So I'm pretty sure that most mounts still have a ST4 port, and it's honestly the first time I've ever used one because, as you know, with PhD and things like that, we're pretty much using computer corrections to the mount and not using the ST4 port. But I was glad that I had one when I found this little guy because it certainly, that's something that you need. So. Okay.
Okay. Ready?
Gentlemen, can I interrupt you? It's a couple of questions that have come in from the web. Dennis wants to know how to polar align during the day. So, are you going to talk more about that later?
Well, I can talk about it now, certainly. Excuse me. So the way that I do it is I have a compass. And so the first thing that you have to know is what your magnetic declination is at your location. Now, you get this by looking it up on the internet. It's pretty easy to look up. If you just Google magnetic declination, you'll be able to put in your location and it'll tell you what the magnetic declination is. What is magnetic declination? What am I talking about? Well, basically, a compass doesn't really point north. It points a little left to north, a little right to north, depending on where you are in the planet. That little bit left or right is what's called your magnetic declination. And so, for example, here in Pittsburgh, my magnetic declination is 9 degrees west. So I know when I'm looking through my compass and I look through the little peephole in the back of my compass, I actually have to point the telescope to 9 degrees, not 0, not north, right? You point the compass to 9 degrees. That'll get you set to north. And then to set the declination or to get your altitude rather, I use a clinometer, and your clinometer is set to your latitude. So, here I'm at, 43 point something, something, something. And I just set that clinometer to what my latitude is to set the altitude on the mount. And so with those two readings, I have a rough polar alignment. Now, it's rough. If we were to try and track stars that way, it wouldn't work so well, but it's certainly perfectly good for what we're doing here. Eric, do you have anything to add to that?
Yeah, I do it slightly differently. I make all the adjustments that Tim just talked about, and then during my practice sessions, I go to the sun, and then I use the dot finder in the high node or the display screen on the back of the camera to say, well, I'm a little bit off. And so then I'll just use the altitude and declination adjustments to center that sun. So if I'm off a little bit and the go-tos are accurate on the mount, that little bit of physical adjustment, putting the sun directly in that high node finder, is good polar alignment. And after that, of course, you're guiding, so you should be all set.
Right.
And there are several other suggestions that people have offered in the YouTube comments about how they go ahead and do it. And one thing I'll add is that if Eclipse Day is the first time you're trying to do this, you aren't listening. You should have done it a dozen times at home before you get close to doing it there.
We're going to talk about that.
We're going to make that point, yes. Right?
Yeah,
Okay.
We're going to make that point over and over again. And Alex, we all agree.
And Dan, how well does Dan wants to know how well the henotic tracker works during totality.
I'll actually show something later on one of my practice sessions, and the answer is better than I expected. But there's a little caveat in there which Tim will describe.
Yeah, and frankly, through totality, the guider's not going to be functioning, but that's only for what, 4 minutes we're going to have for if you're on the center line right now. And for that 4 minutes, you're relying on the mount to track the sun. And in 4 minutes, let's face it, we're not going to have a problem. Or certainly, I'm not going to have a problem at that focal length. I don't know, maybe if you were 2,000 millimeters, you might have more of an issue. But I won't have that problem at my focal length.
Well, if you have a 2,000 millimeter telescope, you have the wrong telescope.
That's what I think too, but yeah.
Okay. Anything else, Alex? Alex? Okay, I guess next. Ready?
Next.
I'm
Okay.
sorry, there was one more comment. I'm turning this on and off because I've got people watching the Oscars behind me, and I don't know if I'm getting feedback, and I forgot to turn my mic back on. Anyway,
Okay.
Max wants to point out, what are you talking about guider? Must be imaging at 6,000 millimeters. And the point is that, you know, at the focal length we're imaging at, you can use a guider, and it does make things easier, but as long as you're watching for most of the time and your mount's behaved and you're polar aligned, you can get through for a while before you know, anything shows
Well,
up as a problem.
Alex,
And there's short exposures.
that's
It
not
will.
correct. I'm sorry.
The issue is not, you know, that you have short exposures or anything like that. The issue is that over the course of, you know, 4 hours that you're going to be shooting to get all the partial faces and everything, the sun will drift out of frame. I guarantee it. You know, you're you know, and certainly with the kind of mount technology that we're using here, you know, it's not like you have a model built and it can track, you know, sub-arc second tracking and things like that. You just don't have it. So the sun will travel out of frame, and that's the issue, is trying to keep the sun smack dab in the center of our frame, or as close to it as we can, so that we can, you know, make sure that we're getting what we're doing. Because I don't want to be out there, in my case anyway, I don't want to be out there trying to bump the mount to bring the sun back into the center, and oh my goodness, I made a mistake and I moved it too far, and that to me is a recipe for disaster. So that's why we're guiding.
So just to pile on that point, the sun will drift no matter how well you're aligned. And anytime you interrupt the process of automation to recenter the sun, you've got to start all over. And that gives you the possibility of things going sideways on you. You don't want to do it. And the guider works. And that's the point. The guider works.
And Jeff just decided to throw in the fact that the guider appears to be out of stock. Out of stock. Anyway, that's it for right now. Go ahead with your presentation.
What are you going to do? All right. So, so I'm going to be talking to you about, as I said, about Solar Eclipse Maestro. It is a complete automation solution for the photography session. Now, it doesn't have anything to do with the mount. It's not running the mount or anything like that. It's just running the camera, but it is an automated solution for running the camera. It supports macOS Snow Leopard through Mojave. We'll talk about that more in a moment here. The current version is 1.9.0 on the website. I wrote to the author and was given a later version. So if you are thinking of going down this route, you might want to try that. His email address is on the website. I'll show you that. And but the way that it works is it uses a script to automate the entire session, so you can get everything worked out beforehand, test the script over and over and over again, so that you can be pretty sure that things are going to work. I'm going to show you how easy it is to produce that script and to test it this evening. Eric?
The Eclipse Orchestrator, that's the PC version. And even though the Mac version has a much prettier interface, as you can see, it basically does just about the same thing. You develop a script, it runs a script, you really don't do anything. The big differences are, number one, Eclipse Orchestrator costs $109. And Eclipse Maestro is free. I guess that's an issue. But you only go to this Eclipse once every so often. So I guess $109 to automated photography Eclipse is a small part of the expenses that you're going to go through. The other thing I ran into is it doesn't support all cameras. So my nice R7 mirrorless camera was not supported. So basically they have a list on their site which shows what cameras they do support, and I found one of the latest Canon cameras. I got it secondhand at KAH, and that's what I have up in the mountain behind me, and it seems to work perfectly. We okay?
Yep, go. All right, so the elephant in the room. As you heard me say a moment ago, Solar Eclipse Micro was written a while ago and for older Mac operating systems. and you know, just trying to get into the author's head a little bit. I don't know this for sure, but I'm assuming that it's not been a very lucrative enterprise for him, and he has chosen not to rewrite to support current Mac operating systems. For any of you Mac users out there, Mac went from the ability to support 16 and 32-bit applications to throwing out support for 32-bit. You have to be 64. There's some user interface requirements now. So newer Mac applications would be a total rewrite. And I think, again, I'm guessing that this author just said, you know what, I'm not going to do that. So he continues to support it. He continues to enhance it, but I think he's just not going to try and go through a rewrite. So what the heck do you do? Well, what I chose to do is go into my closet and find one of my old computers that I wasn't using anymore that still had an older operating system on it, Mojave, which is 10.14. And I just did a new setup on that machine, and that's what I'm using. I did also test using, well, I used VMware Fusion, which is one of the solutions that you can use, excuse me, for virtualization. You could also use Parallels Desktop, VirtualBox, you know, one of these others to virtualize one of the older operating systems on your computer. But that's how I chose to solve the problem.
As far as Eclipse Orchestrator, the only thing you really have to consider is the cost. And even though they say they'll answer support questions, I found that they really don't. And probably what's happening now, and if you haven't already decided what to do and want to use a PC, is that everyone's piling on, asking questions, and you're just not going to get any support. But there is some kind of support online where people will sort of answer questions. And we're going to give you a link where we have the two authors, one for the Mac and one for the PC, who present their software. And we'll show you that link a little bit later. And that's probably the best support that you'll have. But you will find that as you run through this and you run across certain issues, like once in a while this thing quit on me, I have no idea why. You kind of have to keep a corner of your eye on it so you can start a backup if something happens.
Yeah, and
next.
You can go next. I'll keep chatting, but you can move on. The reality is there's just, you know, there's just not a big enough market, I think, for these guys to really put the kind of development effort in there that we would love to see. So there are some things that are a little bit lacking. I will add that the author of Maestro does ask for a donation, and I of course did that because I want to support you know, people that are doing software development that helps me, and I would suggest that if you do use his software and you do make a donation, all of a sudden he got real helpful. So and it is what it is. But anyway, so let's show you how to set things up. Go ahead, next. Eric talked a little bit about camera choice. Camera choice is going to be an important part of what you decide to do here. The author of Eclipse Maestro, Xavier Hubert, and I'm sure I'm saying that wrong because he's French and I'm Italian, so I apologize. But anyway, he recommends Nikon cameras. He said Nikon cameras work the best in his opinion, and they include the most features. He said Canon are also solid, work very well. They may not support all the features. He supports Sony cameras in the software, but I got to tell you, I am a Sony shooter. I'm not talking bad about Sony. I have 4 different Sony bodies over there and tons of Sony glass. And when I first started thinking about this, that's the direction that I was going to go, is to shoot Sony. But really, their cameras just do not do tether shooting very well at all. And you know, it just doesn't work. It you know, misses frames. You have to wait for buffering. I mean, it's just not the right solution. And for me, it didn't work well at all. And like I said, I tried 4 different bodies. I have an A7 IV, A7 V, an A9, and an older 6300. None of them worked well. So I would say avoid Sony, go to Nikon or Canon. I used to be a Nikon shooter, and so I went back to an older Nikon, and it works fine. And so I'm using my D810, and you know, everything there works great. I'm using both a USB cable and a DSUSB shutter release cable. So if you're not familiar with them, go look up Shoestring Astronomy for those shutter release cables. It's probably too late to get one for the Eclipse if you don't have it, but it is a help. Now, I will tell you that my D810 worked just fine in my testing without the DSUSB cable, and it did everything through the USB, but I'm putting it on just to be safe. Eric?
And don't have much to add. I'm just using a USB cable. I've run it a half dozen times. I don't seem to have any issues. Again, you have to be aware of what camera you choose. Go to their list, see what cameras work. And as I said, I just purchased a used 80D. So I now have 4 Canon bodies, only one of which. Actually, my old T3i seemed to work, but it was a bit slower, so I did get the 80D. And if you haven't gone to KEH before, they have some very reasonably priced used equipment, and mine came in perfect shape without too many clicks on it.
Okay. So next I'll mention a few things when it comes to setting up your mount. In my case, I'm going to be in Texas shooting this thing, and the Eclipse will go through a meridian flip. So I need to make sure that my mount can track past the meridian, so that I don't end up having a problem there. So you know, make sure that you can set your mount to track past the meridian. Make sure you set solar tracking speed. You know, especially if you're not going to use the guider, and you're going to try and keep it centered manually. Make sure that you're using a solar tracking speed, and you know, so that the mount moves at the right rate. Also, you know, if you didn't want to track and you didn't want to take on that complexity, you know, another approach that you could take is to just set up a still tripod with a wide field, you know, like a camera lens on there, something that will take in the entire path of the Eclipse. Just let it sit. Don't worry about tracking. Don't worry about guiding. Just put it on a fixed tripod. And, you know, you could use something like Stellarium to see, you know, what the path is going to look like and what you can expect. And, you know, set it up and do it that way. Still automate the photography with something like we're going to show you here, but not worry about all the tracking and guiding. So that is an option if you did want to take a simpler path.
And the only thing I'd add to that, right, the other money shot is the wide field shot that Tim just mentioned. Now, I'm not going to try to do both. So my son-in-law is coming along to the Eclipse, and I have tasked him with doing that wide field shot. And he is practicing that as well. And I'm going to show you a picture of what he's done. And there's a couple of tricks to doing that. We're not going to cover that in detail, but I think if that's the second shot you want to get, and maybe the third one is a video of everyone saying, as the Eclipse start and applauding at the end, that would be number 3 that you might want to get. But that should be fairly easy. Next.
Okay, so these are the steps that I'm going to show you, that I'm going to talk about first, and then we'll show you in demonstrations. But you basically just select the Eclipse that you want to shoot. You set your location. You have to set some things in the software to update the solar radius. We're going to talk about that. Set the lunar limb profile. We're going to talk about that. Set up your camera, you know, configure the camera that you're using. Create a script, which is a couple of clicks, very easy. You can modify the script if you want to do something special, and then practice. And so we're going to, like I said, we're going to go through these steps. Eric, anything to add before we move on?
Yeah, practice.
Yeah, practice. Yeah.
Practice. You can't understand how important practice is. I know it sounds redundant, like we're lecturing you, but if you don't practice and you get out there and you get excited, something is destined to go wrong. And again, you have your 4 minutes. That's all you have. And you don't want to be mucking around with a computer or watching anything but the event. What are we going next?
Hit it. Yep, hit it. All right, so selecting the Eclipse is pretty trivial. There's a drop-down list. I'll show you when we do the demonstration. There's a drop-down list. You just click on it and say, this is the Eclipse that I want to shoot. Boom.
And same way in Orchestrator, except it's not as pretty an interface. Actually, it's a little bit different. I use their wizard to do it, and like 99% of what's in the wizard is correct. So you just click in the file menu, bring up the wizard, and the first thing they do is have you select the event.
Okay.
Next.
Next. Observer location is also pretty obvious and trivial, but you set your latitude, longitude, and your elevation, get the right time zone, entry in there. You can save multiple locations. So if you're an Eclipse chaser and you're going to be in, Australia for the next one, or Chile, or wherever the next one's going to be, you can put multiple locations in this and use that each time that you chase an Eclipse around. But that's more than what we're going to talk about tonight.
And the wizard in Orchestrator, you see it, I put a little red box around it. You set in your location. I'm a little bit later, I'm going to bring up a site which is really a cool site to set your location, but I'm sure everyone knows how to set a location and their altitude, and you simply fill it out. And again, you move on through the wizard.
Okay, so in a link that we're going to show you in a little while, the authors talk about using their software. And one of the points that the author of Eclipse Maestro makes is that the accepted size for the sun was established in 1976 at, and I can't read what the heck it is there, 959.63, I think it was, arc seconds at 1 AU. And apparently, that size is too small, and that we should be using a larger size for the size for the sun at 1 AU, and that is 959 point, what does that say, 98, Eric?
98.
See, yeah. So, this is just the number that he said to plug in. I'm accepting it. I'm accepting his direction and putting it in there. The reason that it matters is if the sun is bigger or smaller, it affects the timing for things like Bailey's beads and diamond rings and the duration of the eclipse, things like that. He said that if you're smack dab on the center line, it probably doesn't matter a whole heck of a lot. But if you're off the center line at all, which, I mean, most of us are going to be off the center line somewhat. If you're off the center line at all, it starts to have more of an impact. And obviously, the further away you are from center, even in the path of totality, the further away you are from the center, the more of an impact this has. So he said his recommendation is that setting 959.98. So it's just a one-click thing, and that's it.
Now in Orchestrator, it doesn't have the same kind of, it's not part of the wizard, but once you complete your script, you can go into their regular menu. I didn't show it here, and you can select 959.98 as your solar radius. So that's probably something after you make your initial script that you go in and make a correction for.
Lunar limb profile is the same thing, and this is just another setting. I'm almost certain that it's correct by default, but I went in and made sure that mine was set correctly. You want to use the NASA LRO for the lunar limb profile, and what this is the profile of the edge of the moon with all of its craters and peaks and valleys. You want to have that to be as accurate as possible, again, for Bailey's beads, diamond rings, all that kind of stuff. Now the Lunar Reconnaissance Orbiter, that's what LRO stands for, took a bunch of data, and they produced a lunar limb profile from that data. And so that's the most accurate one that's available, and that's the one that you want to use.
And again, in Orchestrator, it's not part of the wizard, but you have to go in and make that selection from the drop-down menus. And in Orchestrator, I didn't put in a picture of it, but there is an animation where it shows the different mountains that actually appear as part of Bailey's beads, and it's kind of a cute thing to see.
Right. Okay. Setting up your camera is pretty trivial. When you when you connect the camera, it'll come up in the list here. I'm sorry, I'm pointing at on my screen and you can't see where I'm pointing. It'll come up in that column that you can't edit there. That's the one that says detected. You just name your camera over on the far left, and if you're using the serial cable, then you indicate that there. But it's really just it's pretty trivial to just select it and go for it.
One point to make about Orchestrator, if the camera's not connected, you can't do the wizard and you can't really do anything else. So the first thing is your camera has to be connected and turned on. When you do, when you choose camera, that drop-down menu, it'll come up. Then you can name it and you can move. Again, it's part of the wizard. It's not part of one of the, although you can use it in the drop-down menus, it should be part of your wizard setup.
Okay, next one. The next thing we do is create the script. I'm gonna show you exactly how to do this, but it's pretty trivial. You just kind of walk through these screens. The first one just confirms the eclipse and the location. The second one is about your equipment. What kind of maximum exposure do you want? What ISO do you want to shoot at? You know, things like that. And the third one are the events that you want to capture and how many frames you want. So do you want to capture, you know, the partial phases? Do you want to capture the diamond ring? Do you want to capture Bailey's beads, the chromosphere? You just kind of check off the things that you want to shoot, and that's it. And it creates the script from there. You can, of course, modify the script after it gets created, and there's an entire scripting language that he has documented in the help in the application, but it's a little easier to get it off the website. You see the long address there. I went out and found it on the website and found that. So if you're looking for this, come back to our video and pause it here and go type that in, because it took me probably 15 or 20 minutes to root around and find it. So I found it and put it in for you there. Go ahead, Eric.
And again, were you done, Tim?
Yep.
Yeah, this is just a wizard that you go through, and it probably looks pretty much the same as in Maestro. Again, the interface isn't as pretty, but basically you're setting up the event, the location, the camera, maximum exposures, preferred aperture, and if you set that up pretty much as requested, the wizard will make a script which is pretty close, and all you have to do is tweak it. The one thing to take note of in the phenomenon is you have to figure out how long the eclipse is and make sure you're not taking too many pictures and there's not time for the camera to recover or not time to get the picture that you want, because all these exposures in the phenomenon during totality are bracketed and they take a finite amount of time. And by the way, if you happen to put in a location that's not in totality or towards the edge of totality, it'll tell you that you don't have enough time to take your pictures that you set up. And that puzzled me for a while, but I just made a mistake on one of the longitude and latitude, and I was never in totality. And it kept telling me you don't have enough time, and there was nothing I could do until I finally figured out I had the wrong location. And once I did, then I had enough time. That's kind of an odd message, error message, but I eventually figured it out.
Okay. So let's do it.
Let's
Eric,
do it.
You want to pass control over to me, and I'll share.
I will stop sharing.
There we go. And let's see if I can do this.
We hold off for a second while you're getting ready, or
Sure, go ahead. Go ahead, Alex.
We got 3 or 4 questions. John wants to know if Orchestrator, the free version, is any good, and what you might miss by getting free instead of paid.
I don't know that answer. Eric, do you?
No, I don't really know how to answer that. Once you figure out how to use it and put it in correctly, it seemed to work fine. And I think you had the same experience with Maestro.
And
it works once you figure it out.
That's the paid version of Orchestrator.
Yeah, that's the paid. Orchestrator is the paid version.
Okay, and you just don't know about the other. So, okay.
But Tim had perfect experience with it, so I think he was fine.
Yeah. Yeah, okay. I didn't have any problem with Maestro at all. Using the free, using his free software. There aren't 2 different versions. He just asks for a donation. which I made.
Yeah, his question was specific to Orchestrator.
Yeah, okay.
I'm sorry. So did we answer the question? Orchestrator worked perfectly once I figured it out.
And you paid for it or you got it for free?
I paid for it.
Okay, so we don't know about the free version. Well, how well it works and what is
No,
different.
but there's a series of features that are only available in the paid version. And then once you look
Okay.
at the features, you'll say, oh yeah, I want the paid version.
Well,
I mean, you're spending all this money, you're traveling to who knows where, you know, the cost of the software is
okay, hold
not
it, guys. We've been freed by our listening groupies. Mike says the free version's useless. Rich says the free version allows bracketing and totality and diamond ring and one other thing. It does not do partial or some other things like prominences and earth shine. And Ernie says the free version's for testing, doesn't get you a whole lot more. And I'm sure it will keep going. But let's get back to the other questions that were already there. Sean wants to know, how do you focus? You going to cover that yet?
No, that's an interesting question. If
Now I'm going to talk about it.
you want to wait for that, because focus is a
Yeah,
big deal.
I'm going to talk about that, John. So if you
Okay.
give me a minute, we'll talk through that.
And John wants to know how to avoid the meridian flip. How do you make sure you're not going to need a meridian flip?
Go to Ohio.
Yeah.
Go to
Okay.
Ohio.
How do you avoid a meridian flip in some place where there's going to be sunshine?
I mean, if you can track long enough past the meridian to get the image that you want without your camera or telescope colliding, or lens, if you're using a lens, colliding with your with your tripod, and you can track past meridian, that's the only thing you can do. But if you can't track far enough to account for where the sun is going to be, then you don't have a choice. You got to flip. It's just like a DSO, right? You can track past a meridian a certain amount, but once you get to the point where your camera's going to be smacking your tripod leg, you got to flip it. Does that answer the question?
There we go. No, yeah. And Max has reminded me, I skipped his question here when I wrote it down. Will shutter lock work without DS-USB?
Will shutter lock work?
Yeah.
Well, I assume what you mean is a mirror lockup. Is that what you're talking about, Max?
Go ahead.
I think he's probably talking about mirror lockup.
Oh yeah, he is. He's got mirror. Yeah, he's got mirror
Yes.
lockup.
And the answer is, I can tell you for sure on the D810 it works fine. I tried with the D7000, and the D7000 definitely worked better with the shoestring cable. So if you're using Nikon, I think the newer cameras probably will be fine just with USB. If you're older than say the D7000 and that time frame, then you might have an issue. And I can't speak to Canon. I don't have Canon.
I haven't had any issue with the USB cable. Although I'm carrying.
Have you ever noticed any mirrors with mirror problems? I mean, yeah. Have you noticed any problems with the mirror action?
No. I mean,
No.
you're talking about really short exposures here, plenty of light. This isn't like dealing with the stars. So that little vibration that you get from a mirror flip is a non-issue for me anyway.
You're caught up.
Okay. So let's look at some software here. We were talking about some of the setup things, and I'm just going to show those to you real quick. Where you choose the eclipse. There are total eclipses and partial eclipse onlys listed in here, but you can just go through and select the one that you want. Now, interestingly enough, you can select an older eclipse and go through and do some of the animations and things like that if you want to do research on them or you want to look around. So that's kind of fun to play with. But anyway, for our purposes, we're going to be selecting the 2024 April 8th total solar eclipse. So we select that. We talked about the solar radius at 1 AU. Again, that's just another selection. We want 959.98. That's on the setup menu as well. Setting up your camera here on hardware configuration, it fills in the detected camera right here. And so it'll tell you what it thinks is out there. You then select the camera model that you actually have, and you can see he supports quite a few different cameras out there, but you select the one that you're actually using. I think they also have a way to support astrophotography cameras as well, but I'm not using one. I'm using just a DSLR. And this entry here is just the name. So you could call it whatever you want. You could call it Frida. You'll notice that you can support multiple cameras in Eclipse Orchestrator or in Eclipse Maestro. So if you wanted to have a wide field camera and a tracked camera, you can run both of them out of a single script. The author recommended that he's tested with 3. He's never tested with 4. So he said, if you use 3, you'll be okay. I've never tried it with 4. It's supposed to work. So anyway, take that for what it's worth. We talked about the limb profile, the lunar limb profile. Again, that's just another selection here. So all of that is pretty simple to do. Just a few little setup things. The next thing that you would do is set your observer location. Again, we showed you this slide, but you just put in your longitude, latitude, elevation. You can look up your time zone. If you have a GPS sensor that you want to connect to your computer, you can get the location directly from the GPS. You can save multiple locations, but it's all pretty trivial. The tough part is writing the script, or not really tough, the interesting part, I should say. You just go to this configuration wizard. Now you can write a script from scratch if you're so inclined. I wasn't. So use this configuration wizard. It confirms the eclipse that you have and the location that you want. You say continue. It says, what's the maximum exposure that you want to allow? I said, I'll let you go up to 30 seconds. I don't care. I'm tracked. This is my my aperture, or as close as I could get. Mine's is actually 7.5, but that's as close as I could get. The ISO that you would prefer to shoot at, you can set that here, whatever ISO you want. The maximum ISO that you want to allow it to change to. If you want to shoot in RAW or JPEG, I'm shooting RAW. Hashtag shoot RAW. And minimum spacing between exposures. I actually don't need 2 seconds here, but I did it just to be safe. But the Nikon cameras, the buffer is really good, and I've got fast memory card, which is another point that I should have made when we were talking about cameras. Forgive me for not making it before, but you really want to make sure that you're using a fast memory card, a high quality memory card. If your camera supports compact flash, put that in. If it only supports SDs, use the fastest ones you can get, because you don't want to be fooling around and waiting on buffering and end up missing a shot. So fast memory. And the name of the camera that you're going to use. Like I said, you can have multiple cameras, so this is the one that you're going to use. The next thing that you do is select the phenomena that you want to capture and how many sets of data that you want there. So do you want to do on eclipse sun? Do you want to get C1 through first contact and last contact? Do you want to get partial phases, and what percentage? This is every 2%. It'll take another shot. Do you want diamond rings, Bailey's beads, and so on? You just select what it is you want to shoot and say go. And it will create a script and ask you where you want to save it. You give it a file name, and that's it. I'm not going to overwrite my script. From there, you load your script, and it'll come up in a file that looks like this. Now, this script is just a text file. So if you wanted to edit it, you can just edit it with a plain old text editor, and this is what they look like. Obviously not real intelligible unless you know the language, but as I said to you earlier, he does document, you know, what this language looks like. And so let's go back here. So anyway, this is the script. This is everything that it wrote. And I'm just going to show you some highlights here. But here we are at first contact, taking some images. Here we are at the partial phases. And you see every 2%, he's going to take another shot. As we get up closer to the eclipse, he's going to start playing voice prompts that says 10 minutes, it says 5 minutes, 2 minutes, 1 minute. So it tells you, take your filters off, you know, all of that stuff. There's voice prompts in there for all of that. And then diamond ring, Bailey's beads, chromosphere, all of these things came out of what we configured. And then here's shot store and the corona that are bracketed from 0.1 all the way up to 8 seconds. He does that a couple times. We get earth shine. So all of this was put in just by running that script. So it's all pretty easy, pretty cool. Now let's talk about practice. We've been preaching practice, practice, practice. Well, the way you can do that here is you can go into simulated time and say, well, I want to start, you know, let's say first contact is here at 18:17. I want to move my clock up to, that would be 6:17 and say, okay. And now you see it's going to jump up here. Whoops, I must have done something wrong. Oh, I should have been put in 5:7, my bad. Anyway, you can see that it's now running a simulation. It shows the moon and the sun up here in this corner. And as we click on here, looks like we're going to be another minute. But let's give it a second here. And you'll hear it actually fire my camera. I don't want to wait a minute. Let's do this. We'll just jump up to second contact. So if we jump up to second contact, we should get a voice prompt here in 5 seconds.
30 seconds.
You hear the voice prompt coming up. And the next thing it's going to tell us is filters off.
Filters off. Filters off.
And then we're going to get a 10-second prompt.
10 seconds.
And now you can hear it clicking, or maybe you can't. I'm hoping you can hear it clicking my camera shutter, but the camera is back there firing away, you know, for each of these things. And so this is how we practice. Now, obviously, I jumped way ahead on the Eclipse. You would start off at the beginning and go through the whole thing, but this is how we practice, and we just allow it to sit there and fire away the shutter. Taking pictures of the sun. So again, the way that I practice is just set it up outside, just like it's eclipse day. I started at the time when I'm going to be taking exposures. I set this thing to jump ahead to first contact, and I let it run through. I'm just going to stop this from taking all these exposures, so you don't have to listen to clicking and behind me. So let me just go back to current time. And I'll stop it. But that's pretty much the whole process, right? There are lots of other nifty things that you can do. Actually, let me do this. Let me go up to second contact and see if I can show this to you. There's a way so that we can look at the lunar limbs here.
30 seconds.
And so what it's showing me is the profile of the moon. And right there, you see the orange lines. That's the profile of the sun.
Filters off. Filters off.
Right? So that's the profile of the sun that we have there. And, we can see exactly as this goes through its animation, we're going to see, the solar profile coming through there, and see exactly what that looks like. So it's kind of a neat little way to see exactly what you're going to be getting during Bailey's beads and diamond ring and all those sorts of things. So I know that was quick. I hope it gave you a taste for you know, for what the software looks like. You know, I'm going to stop sharing my screen here. The point of all of this is to start the start the automation, and then sit back and watch. And so I plan on having my eyes up in the sky. Oh, I didn't talk about focus. I'm sorry. Let me go back to that. Let me share again. I wanted to talk about focus for you. I promised that I would, and then I forgot. There. Share again. So one of the things that this has is the ability to do live view on your camera. And so the way that I focus is I pull up the live view screen. Whoops. And of course we have to have a problem, right? Here, let me just quit and try this again. Recycle my camera. All right, you go away. And let's see, are we connecting? We're not connecting. What did I do?
You want to come back to that, Tim?
Yeah, I'll come back. I'll come back. Let me go ahead and turn it over to you, Eric, and I'll figure out what's going on here.
Okay.
And come back to it.
Oh,
Stop sharing.
let's see. Entire screen. Eclipse Orchestrator. Let's bring that up. Can you see that? Tim, can you see?
Yes, we can.
Okay, nice.
Yes, we can.
This is Eclipse Orchestrator, and I already have a script that I've written. And you can see right now it's 28 days until the eclipse from right now. But let's go through a wizard as if we're writing it for the first time. This is a little bit small. So as I showed earlier, here's your eclipse, drop-down menu, you select your eclipse. The camera I've already loaded in there, it's the 80D, it senses it. The location is, I've gotten at various places. I'll show you a little website that's a little bit later to get your location down to the absolute foot and your elevation. You then set your maximum exposure. This one's set a little low because I think my exposures want to be as long as 8 seconds. But remember, when you're setting your exposures, you have 4 minutes. So if you have bracketed a certain number of exposures and you want each one to be 8 seconds long, you have to be aware you only have so much time during the eclipse. With a 4-minute eclipse, it really isn't much of an issue. But if you are not on the center line and the eclipse is a little bit shorter, you have to account for how much time you have and how much exposures your script is going to allow you to do. And I think if you run into a problem, it's going to tell you you don't have enough time to do your exposures. My preferred ISO here is 200, but when I actually did my practice runs, I started off at 125, and I think the final script that I have on my PC that I'm taking is actually 160. And of course, we're going to get camera raw, minimum spacing 2 seconds, and the voice prompts. And here's all the cool things, all the brackets. If you set up your camera correctly, it'll pretty much write you a reasonable script. But once we actually get the script done, you'll be able to go through and see whether you have any gaps in that. So let's finish the script. And so now we have a script, but we can edit the script. Location times, let's see. Support. Let's bring up the simulated view. Okay, here's their editor, and this is really kind of cool. So it goes through each steps of the eclipse, that the script is written for. And you can use these drop-down menus to change any one part of it if you want, going through from C1 to C2, C2 to C3, and C3 to C4. So these are all the steps which the scripts includes, and what it's going to do and how it's going to bracket it. So and if you find that you have a gap in here and you want to fill it in, you can simply click on this and add insert before and put in a new exposure if you want to go through and detail that. Now, I think in Maestro, you had to go through and edit text. In this case, you can, but this little editor really makes things a whole lot easier. And you can see all the exposures through all the different phases. And in addition to that, it has a function here where it will visualize. So this shows you all the different phases and all those little dots, if you can see them, are all the exposures. Now you really can't see much here, but you can zoom in. Let's see if we can zoom in. So here's totality here. So let's zoom in. And if you find that you have some gaps, like perhaps there's a gap here and you want to fill that in, you can go back to the editor and you can fill in an exposure, but it looks pretty much like the entire eclipse is well bracketed. So each one of the black dots is an exposure, and the exposure here during the diamond ring. So it looks like this is a pretty well filled out script. But if you set up your script and you find that you have some gaps, you can always fill them in. So this shows the diamond ring, totality, Bailey's beads, and then back out into C3 to C4. And you can do all the editing here in a graphical interface. So zoom out, zoom out, zoom out. So there's a visualization. And that's kind of a cool thing, especially since someone like me doesn't really know about editing scripts, or if I did edit a script, I'd probably make a mistake. So this is a very helpful thing to edit your scripts. So now you've written your scripts. You've saved your scripts. I'm not going to save my script. And if you have made a script and you want to open it up, nope, I'm going to cancel. You can go in and open up your script. But we're all ready to go. So simulations. So we don't have any sun in here. Let's go to real time and simulated time. So let's simulate second contact. So we're almost ready, and in just a couple of seconds, it's going to say filters off, but I doubt if you can hear it, but let's let it go through. Can you hear that?
No.
It just said 30 seconds to go. Filters off. So then you have to reach up and take off your filter. One of the things that can go wrong, you're sitting there looking at the eclipse and you fail to take off your filter. And now it's taking pictures. And you have to remember to take off your filter. It sounds like a dumb thing to suggest. Of course you have to take off your filter. But if you're enamored with the eclipse and you forget and your filter's on, then you don't have pictures of anything. And now it's taking a bunch of pictures. I don't know, can you hear any of that? You probably can't hear it.
No, we can't.
That's all right. It's taking pictures. And you can see from the display that it's bracketing it. I've set this one for a 2-second maximum. I'll probably go a little longer, maybe 6 seconds. And you see now it's bracketing totality. And so then when you get to the end, it's not there yet. You got to remember to put your filter back on. You don't put your filter back on, you overexpose everything, or maybe worse. So let me go back to real time. So what does a practice run look like? Let's see if we can bring this up. Oh, I thought I had a picture of a practice run. Well, I don't have a picture of a practice run. Oh, here it is, practice run. Can you see that? I'm sharing the whole screen.
Yes, we do.
See that? So here's what a practice run looks like. And you can see in the beginning, I'm just taking a couple of shots, clicking the structure. Here, I'm positioning the sun in the center of the frame. So this is what you do at the beginning, including focus, and I'll discuss that in a second. So your guider, when you set it going, the first thing you do is you make sure that the sunspot is in their finder. And it's a fairly broad finder, and all you have to do is make sure the sun is somewhere in that finder. But you also want to position your sun in the middle of the frame. And just because it's in the middle of the finder doesn't mean it's the middle of the frame. So you have to kind of open it up one way or another, either with just a little display in the back of the camera, and then position it around. And that's what I've done here. I position it, and it will still, the finder sun will still be in the finder of the high node glider. And when it's in the position of the frame on the guider and in the position of the frame actually on the camera, that's when you start your guider and not before. And you can see it's taking a bunch of pictures, and that sun is taking pretty much right on target. And you see all these overexposed pictures. Well, obviously it's taking long exposures, but the filter's on, and that's just what it's going to look like because I don't have an eclipse. And then it's done with all the bracketing. And then at the end, you put the filter back on and you see the rest of the exposures. Now in this particular dry run, I've set it for 2 minutes instead of percentages. I may go back and change that to 1.5 minutes or a minute between exposures during C1 to C2 and C3 to C4. I'm going to have to practice 1 or 2 times before, but that's what a practice run looks like. We can close this. What about focus? Let's stop sharing.
And Eric, I can bring mine back up. I figured out what was going on. So.
Okay, you want to do that, or should I talk about focus?
Yeah, well, that's what I was going to talk about is focus. That's why I said that.
Give one save there.
Okay. You go ahead and pick that up. I'm going to ask a couple of questions. Does Orchestrator give you a total number of exposures that it's going to take? Does it tell you about that before the run?
I don't know. It might, but I think you can calculate it, especially if you look at the script and you see how it's bracketed, and then you have how many exposures C1 to C2. If it's 1%, you're going to have 100 before and 100 after, and then you'll have to calculate. I think when I went with a 1%, I ended up with about 210 exposures.
Okay, thank you.
But I'm having a little bit less. I thought that was kind of a lot.
Okay, Max, that'll tell what we know about that one. Rich asked, look, you're using F20. Are you using a solar? Is that because you're not using solar film during that time? Do you recommend F20? What's happening there, Coach?
Well, basically, I just fiddled around until the exposures matched what image I saw with the sun, and I was happy with it. So I ended up with basically 160 as an exposure. So in this case, it's a telescope. And so I just set it at 160 and F200. I manually set that from experience.
Oh, okay. Okay.
Actually, the presets that they suggested were a little overexposed. So I just played around with the, with the speed and the exposure until I was happy with it.
Okay, and that's stuff you can do during practice. You don't do it the day of the eclipse.
You don't do anything the day of the eclipse except set up and click the button, focus, and position the sun, and then sit back and enjoy it.
And I think we are caught up. So
Okay,
go
so
ahead.
let's talk focus then. So I'm sorry, what happened to me and the reason that it wasn't working is that I've been practicing so much today that my camera battery went dead. So it wasn't a software issue at all. It's just the battery in the camera went dead. So I swapped out batteries real quickly here. So the way I focus is I go into live view. You can see that you can bring up the live view on your camera, but this is bringing up the live view here on the screen. Now it's just taking a picture of my ceiling right now. So, so forgive that, but you would bring up the live view and you would have the whole solar disk here, right? And you'd use this for positioning as well. But you get the image of the sun, and then you see where I have this box. This is where it's going to zoom in when I change the scale. And so I set this box to a sunspot, and then I just zoom that thing up to 4 times or 8 times, whatever it is, and it'll zoom in on where that box is positioned and show me the whole thing and allow me to adjust focus manually. I'm using just a manual focuser and adjust focus on that sunspot and dial that thing in to where I can see it the best. What I plan on doing is also bringing that up during the partial phases once I have once I have a crescent there from the eclipsed sun. I'll between 2 of these images during a partial phase, I'll bring that live view up as well and just check and make sure that that crescent is real nice and sharp, and maybe tweak it a little bit. But that's really the only thing that I plan on doing for focus is using that live view. Eric, do you have another?
And just to be clear, you do not have control over the focuser of the lens itself. You need to reach up and touch it.
I do not, because I chose not to add that level of complexity. Now, if you're using a camera lens and not a telescope, if you were using a lens, then it can be controlled through the camera, and Eclipse Orchestrator can control it that way. Okay. But I still, I don't think that it's going to focus the way that we would focus. And so I chose to do it manually.
Okay, thanks. We're done.
Okay, no, we're not quite done. Focus.
No, you're still going. We're done with the questions.
I did not have a lot of luck with live view in Orchestrator, and I don't know why. Not sure, but so I went with Backyard EOS, which I've used a lot. And basically, before I got going, I set up Backyard EOS. I did the same thing that Tim just described. I zoom in, and then I reach up physically to touch the focuser. But there are a couple caveats to that. You can't do that in full sun. You have to have a sunshade, and you have to have your computer in the sunshade, like the first image that I saw of my setup. If you don't do that, let me just bring this up. Because it's a little bit tricky. Well, that's not going to work. Let's see if we can zoom in here a little bit. All right, that's not going to work. So if you remember the picture, the sunshade was set up on the south side of a telescope. That won't work because the sun's behind you and you can't reach your telescope. Now, this might seem kind of stupid, like, of course that's the case. But what you have to do is you have to set up your computer and your sunshade on the north side. So physically you can reach up and touch your focuser and still be totally shaded and see your computer screen. And so then you can zoom in and tweak it, and hopefully there's a sunspot there or a nice edge where you can get good focus. If you don't do that, you're not going to get good focus. If you are in the sun at all and you don't have a sunshade, your pupils will be so, small that you won't be able to see your computer screen. And the other thing is, I have a 110 power supply that I'm taking. If you don't have that thing powered up on a 110, your computer may not be able to go to full brightness. And what's more, if you go to full brightness and you don't have a power supply, you're going to run out of juice on your PC. So you have to be on the north side of a telescope with an AC power of your laptop in a sunshade so you can physically look at the computer screen, reach up and tweak it and bring it into focus, whether you're using live view on Maestro or whether you're using backyard EOS on Eclipse Orchestrator. Or perhaps you can get live view to work with Orchestrator. I just haven't been able to do that. And if you don't have good focus, then none of your pictures are going to turn out. The other thing about focus, as you get closer to totality, you may want to refocus. If you do that, your script will stop because you can't have two things connected to the camera at once. So basically, you'll have to quickly make your focus and go back and run the script. Because during that time, and if you do it, like 10, 15 minutes before totality, you should be fine. You shouldn't really lose anything. So that's my commentary on focus.
Now, I can tell you in Maestro, you can bring up live view while it's running and it's fine. And if a shot does come up that it wants to take while you have live view, it automatically closes live view, takes the shot, and then opens it back up. So Maestro does a pretty nice job with live view. And, I have the similar kind of solar shade on the computer that Eric's talking about, and I just throw the hood over and, get in there, and my wife is going to laugh at me, but, I can see perfectly, and I just, reach up to the telescope and adjust the focus that way. So that's all.
On the north side, on the north side,
On the north side, right.
On the north side, close enough that you don't interfere with your telescope, and you can
if you
reach
practice. If you do this in practice, you're gonna figure all this stuff out, because all of a sudden you're gonna say, "Oh, I can't do this. I got to be over here. I can't reach."
Yep.
I mean, this is some of the reasons why Eric and I are saying, get out there under the sun, set it up, run the practice sessions, just like it's Eclipse Day.
It may sound like we're kind of preachy about this, and I guess we are. Because we want you, if you're going to get out there and do automated, we want it to be a successful experience where you enjoy the eclipse, not mucking around with a damn computer. And the other thing I would say, if something goes wrong and the whole thing, collapses on you and you can't, don't worry about it. Enjoy the eclipse. That'll be your experience. And you'll tell the story about how you spent all this time with automation and all you saw was this eclipse, which will be perfectly fine. You'll get it next time in 30 years, is it?
Yeah, 30 years. I would agree. I would say that, what do they tell us in the Army? Prior planning prevents piss poor performance. And so, I think if we take our time and we run through this enough times, you should be able to chase out most of the gremlins. But, if something sneaks through, something happens, my plan is to turn it off, close the cover, shut the camera off, and sit back and watch it, and not worry about it, because it's just too special an experience to miss with your head down, trying to figure out what's going on with a computer. It's just not going to happen. So
I even have a plan to, if it's clouded out and we can't find a nice clear spot, what do? I set up the automation. I let it take a bunch of pictures. It gets dark, and that's my image. Where it got dark all of a sudden, then it got light again, and I missed the eclipse, but I got a picture anyway.
Yeah.
Okay, Tim, what's next?
I'm out of stuff. You want to bring up your your links, you want to share your screen?
Do you want to talk, when do you want to talk about, should we photograph the eclipse? Or do you want to wait?
Well, go ahead.
Do we want to do that? Okay, you first.
Well, and I think this kind of fits into what we were just saying is, should we even attempt this? And, what is this something that we should even try? From my perspective, the reason that I'm doing this at all, that I'm doing all of this automation at all, is because I think I can be successful with a solution like this that allows me to practice first, get everything worked out first, and not be sitting there clicking things around on cameras and everything else. If I've done this correctly, I should be able to press the button, say go, and sit back and let it run. And that's sort of my approach. So we've heard people say, if this is your first eclipse, don't photograph it. I purposefully chose a solution like this so that I could photograph it, even though that it's my first time trying to photograph an eclipse. So that's my 2 cents.
I don't want to give the counter argument, but I was told, don't photograph the eclipse if this is your first one. And I don't want to say that would be my recommendation, because I want to have that money shot. I want to have a couple money shots. But you have to think carefully of, do you want to put out the energy, and are you confident enough that you can learn whatever software you choose, so when you go there, you can still enjoy the eclipse. So with that thought in mind, I'm going to share my screen. I think I was sharing my screen.
No?
Okay, I'm going to share my screen. Share entire screen. In 2017, we went to the middle of Nebraska. And that's me, we kind of out of focus with the green top and reclining, getting ready. So I was told, don't photograph the eclipse, but I was going to do it anyway. So I took my DSLR camera, and you can see that I just was going to hold it above my head and click the shutter. And there I am. And when I clicked the shutter, the flash went off. And so now we have a video of the idiot, me, watching the eclipse, clicking the flash unintentionally. And by the way, I never got a picture. So I am, even though it's completely out of focus, that is me. So if there's something not to do, this is it. And by the way, I did see the entire eclipse. We will turn that off. It's embarrassing enough. By the way, the thing that people do, if you haven't been to an eclipse when it starts, they let out a deep, like, sigh, and you can just hear 30 people going all at once. And in the end, they all do the same thing. They all applaud. Let's get to the end. Now the end. And I'm still trying to take pictures. Oh, who knows why. Well, I don't think we're going to see that, so let's stop sharing. Okay, the last thing, we want to show a couple links. Tim?
Yeah, did you want to bring up the last slide?
No, I'll bring up the last slide. I should have done that while I had it.
That's all right.
Entire screen. Let's go to the last slide. There are the links to Eclipse Orchestrator and Eclipse Maestro. And here's another presentation, the 2 authors of the software. This is the, I can see that?
You're not sharing.
Am I not sharing? No. Let's try again.
There you go.
Sorry about that. So there are the links to the 2 pieces of software. This is a link to a presentation by the Kalamazoo Astronomical Association, where the 2 authors get on and each go through in detail of these pieces of software. And this last one is a detail rotation. I just wanted to share this. Let me bring this up. So this is a map of the eclipse path. You can locate your location anywhere by just doing the little search up here. Put in your town, and provided it's a town on the map, it will find it. This is my location. So if I zoom in to Salina, Ohio, this is the inn that we're staying in, and this is their parking lot. And this is exactly where I'm going to be. And all the coordinates, if we go over here and click on this link, it'll give a simulation of the eclipse and give all the parameters of it. There's a little shadow going across. And if we click on the other link, it'll give the exact location, the duration, everything you need to know to set up either one of these pieces of software. So I thought this was kind of cool. We're going to be right, I think I'm going to be right there, pointing out to the south. I guess the south is this way, with my telescope on a clear day. By the way, when I said that, I've crossed all my fingers for the clear day.
Yeah.
Tim?
You know, something else that I did want to mention that you might want to think about, having nothing to do with actually photographing the eclipse, but where I'm going to be in Texas, and pretty much everywhere that I've checked out along the path, they're all sort of predicting these massive traffic jams and you know, big travel problems if you're trying to move around on eclipse day. So you know, one other suggestion that I might make is, you know, get there early, be ready to go long before it's time to actually shoot the eclipse, because I think most, especially these smaller towns, are looking to have some real traffic issues along the path.
Yeah, I mean, you can be anywhere. You can be at a truck stop.
As long as you're in the path.
As long as you're in the path. You don't have to be in a stadium with 50,000 other people, which would be a nightmare, which I think happened down at Champaign in the 2017. And then there was a traffic jam going in, traffic jam going out, and they only got 30 seconds of totality anyway. You can be anywhere in totality.
Yeah.
We have a couple of questions on YouTube. Chris wants to know, has anybody thought about capturing the comet during totality?
I think it's going to be pretty faint. All the research that I've done says it's going to be pretty faint. My field of view should be wide enough that I might be able to catch it. I'm also going to set up a wide field shot and try and catch, you know, Jupiter and Saturn. So if I get that wide, I'll get the comet if it's there, but I think it's going to be pretty faint. Can't hear you, buddy.
You're muted, Alex. Alex, you're muted.
Does Chris wants to know, should he do the meridian flip before or after the totality?
That's a good question. I'm going to be in Texas, and based on looking at it in Stellarium, the totality is going to happen, like, I think it was like 15 or 20 minutes after the meridian crossing. So I set up my mount to track through, and I made sure that I can track through the meridian. You know, I can track up to 30 degrees past. I made sure that I could track beyond it. Now, frankly, if I miss a couple of snaps in the partial phase, I don't care. So I'm gonna let it track through, catch totality, catch the Bailey's beads and the diamond ring on the other side, get into the partial phases after totality, then flip. That's my plan.
Yeah, and I'm going to be in Ohio, so basically the eclipse happens after the sun passes the meridian. So
But I think you really have to look at your location and figure out when it's going to cross, and then figure out the best course of action. But I do not want to be trying to flip anywhere close to totality.
by the way, the calibration in the high node is for AM or PM. So I don't know whether that's going to affect tracking. You may have to recalibrate if you do flip.
And so it depends on your mount capacity to track past the meridian. It depends on a whole lot of things, and you're going to have to think that out on your practicing as well as you can.
And to continue Eric's point, Alex, the way that works on the high node guider, there's two buttons, AM and PM, and you can. So the way what that's for is basically storing two different setups. So what I plan to do the day before is set up and get the mount tracking before noon, and store the AM setup. Then flip afternoon, do the PM setup, so that when I do my meridian flip, I'll only have to press one button. I won't have to recalibrate the mount. So that's the plan. Hopefully it'll all go according to plan, but that's how I plan on making the high node guider work.
Okay, Eric, while you were showing that, I don't think people got a good shot at that. So if you want to show the guider.
Actually, if you just go to the high node website, they give you some pretty good pictures. I was just holding it up. I don't think my camera's going to focus that well.
Okay. Do both programs work with both Windows and Mac, or are they restricted?
No.
No.
Maestro's Mac, Eclipse Orchestrator is Windows.
Okay.
Yep.
And I believe we've caught up at all these questions over here.
By the way, I'm running Windows 10. I don't know if it works with any other Windows.
Okay. It's back to Patrick.
All right. Well, that was a great presentation, guys. Very helpful. So, of course, we can all read manuals and online forums and whatnot, but nothing beats having a real live demonstration by folks that have actually used the software. So, and it's obvious that the two of you have put a ton of thought and planning and practice into setting this up. So, but I appreciate the advice at the end too, which is that even with all the planning and all the practice, things can go wrong. And so just to kind of keep in mind that, hey, if your software goes wonky, if something's not working out, just be ready to scrap it and look up, because it would be a real shame to spend the whole eclipse fighting with a computer or a telescope or something and miss the whole thing, right? So
worst case, you set it aside, you lean back, you enjoy the moment. And I can tell you, I've only been to one, but you will never forget it. You just never forget it.
Yeah, so, but hopefully it won't come to that, and things like this will help to make that happen. So, all right, well, it looks like we've got all the questions, so we will see everyone next week to learn about Craig's remote observatory. And with that, Terry, you can take us out. Good night, everybody.